Hello everyone, good evening. I hope all of you are good and I am also fine. So today I will take another class from physics from related velocity, that is from the chapter motion in a straight line, and this will help you for the preparation of NEET, JEE, BCET, UPC, WBJEE, TBG, etc. and UPS also. So our today topics is relative velocity. So there are three cases are there in relative velocity. First cases are in relative velocity. There are three cases are there. Okay. In first cases, when two objects are moving in a same straight line as same direction. Case number one, when two bodies moves in a same direction. Okay, same direction. In that case, what will be the relative velocity of one with respect to another? Okay, suppose this one is one object, is object A, and its velocity is BA, and this one is another object, it's moving in the same direction, and this one is B and its velocity is BB. Okay, now relative velocity of BA with respect to B we have to find out. So the relative velocity of A with respect to B will be BAB equal to BA minus BB. So BAB equal to BA minus BB is the relative velocity of A with respect to B. Suppose, for example, let's try to give one example. Suppose one object is moving in the direction with velocity 50 km per hour, and another object is moving in the same direction with velocity 70 km per hour. Okay, so here relative velocity of 1 with respect to 2, it will be B1 minus B2, that is 50 minus 70, that is minus 20 km per hour will be the relative velocity of 1, that is A with respect to B. Got my point? Clear this much? Okay. Now case number 2, when two bodies moves in opposite direction. When two bodies moves in opposite direction, okay, then what will happen? Then suppose this one is A and it's moving with velocity BA in that direction, and this one is B and it's moving with velocity BB in that direction. Okay, now in that case the relative velocity of A with respect to B will be what? BAB, here BA minus BB. Okay, so BA plus BB, so BA plus BB. Okay, got my point? So here, if they are opposite direction, if two bodies are moving in opposite direction, then relative velocity will be the sum of the two velocities of the two bodies, and if they are moving in the same direction, then relative velocity will be the difference between the two bodies, difference between the velocity of the two bodies. Okay, got my point? So here, suppose for example I consider one body is moving, suppose B1 with 50 km per hour, and B2 is moving in the direction, that is opposite direction, B2 is 70 km per hour. So in that case, B1 with respect to B2, that is relative velocity of 1 with respect to 2, that is relative velocity of A with respect to B will be 50 plus 70, that is here it will be 120 km per hour. Okay, so this one is the second case of relative velocity, and another case is there. Okay, relative velocity. So move on the next case. So here case number 3 will be when two bodies moves in opposite direction, moves at an angle theta. Okay, so in that case what would be the relative velocity? Suppose this one is body A, this one is body B, its body A, and its velocity is BA and its velocity is BB, it's moving in the direction at an angle theta. So in that case, relative velocity BAB will be BA square BB square plus 2BA BB cos theta. So this will be the magnitude of the relative velocity. Okay. Next, that is river case. Okay. If I consider this one is one river and this is the width of the river and this one is the width, D is the width of the river. Okay. If one wishes to move in the direction, move here. So this is the velocity of stream, there is river, velocity of stream with velocity river, and if we move in the direction, if this is the velocity of boat, and it will be the velocity of the resultant velocity. Okay, here it will be the velocity resultant velocity. Okay, so in that case it moves at an angle theta or at an angle whatever it may be. If someone wishes to go this side, exactly opposite side, then he or may the boat should be move in the direction. Okay, in the direction such that the velocity of stream or velocity of river can push here in that way. Okay, so we will do some questions from the topics also, from relative velocity and river cases. So you have to remember, if one is there at point A and he wishes to go at point B, that is exactly opposite direction, then the boat should be moves in that direction, that is at an angle theta. Okay, in that direction to move, because if the boat is moves in the at an angle theta in that direction, then the velocity of river or velocity of stream will it moves here. Okay, push here. If you move in that way, and the velocity of river or velocity of river will push you at here. Okay, so this is the river case. We will do some questions from the topic. These are the questions. Now we will do some numericals from the previous. So our first question from relative velocity is the driver of a train traveling at what 115 km per hour sees on the same track 100 meter in front of him a slow train is traveling in the same direction, that is 25 km per hour. Suppose this one is railway track. Okay, this one is one railway track. Okay, here is one train is there, here is one train is there. Okay, there is one train, and he shows the driver is locomotive driver is here. Okay, and the speed of the train is B1 is what 115 km per hour. Okay, and in front of him, that is suppose at a distance what, at a distance of 100 meter, at a distance of 100 meter he saw another train in the same track and moving at a speed what, moving at a speed, here is another train. Okay, here is another train moving at a speed only 25 km per hour, and this in front of him, this train is in front of him just only 10 meter. Okay, 100 meter away from the driver or from the fastest moving train. And if this is slow, if the velocity of the train is 25 km and its velocity is very fast, so it will be collide. So to avoid the collision, the driver of this train is applied, this locomotive driver applied brake. Okay, after applying brake, there will be retarding force and deceleration will be started. So what will be the retardation? Okay, retardation is what, that is negative acceleration is what we have to find out. So here relative velocity will be B12, relative velocity of 1 with respect to 2 will be 115. They are in same direction, that is they will be subtracted, it will be 90 km per hour. Okay, 90 km per hour. Got my band? Okay, now you put 1 km per hour means 5 by 18. If you cut this one, it will be 5, that is 25 meter per second. It will be meter per second. I converted this kilometer per hour in meter per second. Now here, look at here, U is what, sir? 25 km per hour. If locomotive driver is applied brake here, then this train should be the velocity of the train should be 0 here. Okay, the velocity of the train must be 0. That is final velocity of the train, fastest train will be 0. So B will be 0 here, and S is 100 meter. So A is what we have to find out. So there is a formula, B square minus U square equal to 2AS. So B is what, sir? 0. U is, sir, what? 25 square. 2 into A is minus A. A is what? A is minus A here, because A is retardation, is not it? So it will be 100. So minus, come here. So it will be 25 into 25 equal to minus 200 A. So this 200 A. So if you cut by 20, it will be 8. 25, it will be 28, and A will be 25 by 8. It will be 3.125. So which option is correct, sir? Option D is the correct answer. So option D is the correct answer. It is 3.125 meter per second square. Okay, so option A is the correct answer. Sorry, option D is the correct answer. Option D. So what I have given, let me explain the question shortly. One train moving fastest train 115, that is 115 km per hour, and in a railway track, and another track is the locomotive driver of the fastest train. So another train is there, and the speed of the train is only 25 km per hour. So they will collide each other. To avoid the collision, the driver of this locomotive of the train is applied brakes, and at a distance of 100 meter. Okay, so now we have to find out, after applying brakes, we have to find out the retardation of the train, okay, to avoid the collision. So this is the answer. So what I am doing, first we find out the relative velocity of this train with respect to train. After that I convert it meter per second. This one is given. So U will be this one, B will be 0, because after applying retarding force, the train will be stop here, must be stop here. The train must be stop here, is not it, at a 100 meter distance, otherwise they will collide each other. And B is 0, S is 100 cm, A is minus A. After applying this formula, we get A is 3.125. So 3.155 is the retardation, okay, of the train. So we move on the next question, that is question number 2 of today's class. So students, our next question, question number 2 from the relative velocity is a train of 150 meter length going towards the north direction at a speed of 10 meter per second. So velocity of train is given here. So velocity of train is 10 meter per second, and the length of the train, that is L or S, is 150 meter. Okay, and a parrot flies at a speed of 5 meter per second. That is velocity of parrot is what, sir? 5 meter per second. I consider towards the south direction. So one train is moving in the direction. Okay, this one is, suppose this one is one train. Okay, and one parrot is moving in the direction. The length of the train is what, sir? L equal to 150 meter. Okay, and the speed of the train is 10 meter per second, and parrot is moving in the direction, in that way. So velocity of parrot is what? Minus 5. It is BP, minus 5 meter per second. Why? Because if I consider this one is positive direction, then it will be opposite direction, no? That's why there will be negative. So relative velocity of parrot will move with respect to train will be PT equal to PP minus BT. So it will be minus 5 minus 10, that is minus 15. So if I consider only magnitude, then PT will be plus 15 meter per second. So what the time taken in the parrot railway track. So the time taken by the parrot to cross the train. So how much? Train will move in the direction, this speed, and parrot is moving in the direction in a railway track, on the track in the spiral. So what will be the time needed to cross the train by the parrot? Okay, so we have to find out this one. So here velocity is given, length is given, so time we have to find out is what. So come here, we know that, sir, time is what? Distance by velocity, is not it? Time is distance by velocity. So T equal to distance is what? 150, velocity is what? 15. So it will be cut this one, it will be 10. So time is 10 seconds. So 10 seconds will be needed to cross the train by the parrot, okay, in opposite direction. So which option is correct here, sir? Option D is the correct answer. So option D is the correct answer here. Understood? So let me explain again in 10 seconds. Here given velocity of parrot, one train is moving with a speed of 10 meter per second and the length of the train is 150 meter, and a parrot which is flying parallel to the train but in opposite direction with a speed of 5 meter per second. So we have to find out the time needed to cross the train by the parrot is what, okay. So for that I find out the relative velocity of the train with of the parrot with respect to train is bb minus bt. Since they are coming in the same direction, that will be add up, so it came minus 15 meter per second, that is 15 meter per second relative velocity. So distance is given, length of the train is 150. So from that the relation, that is velocity equal to distance by time or time equal to distance by velocity, we find the time needed is 10 seconds by the parrot to cross the train, okay. Got my point? Fine. So we will move the next question now. So students, our next question, that is question number 3 from the relative velocity topic is: a bus is moving with a speed of 10 meter per second on a straight road. A scooter wishes to bus, that is what is given here, speed of bus is given 10 meter per second. A scooter wishes to overtake the bus in 10 seconds, 100 seconds, that is time is 100 seconds. If the bus is at a distance of 1 kilometer, the distance is 1 kilometer, that is 1000 meter. From the scooter is, with what speed the scooter should chase the bus, that is velocity of scooter is we have to find out. In the same question, this is like same question. Suppose this one is, here is one scooter is there, okay, and scooter is not like a scooter, or scooter is there, and here is one bus is there, okay, there is one bus, and bus from the scooter is scooter, this one is bus, suppose, okay. Don't laugh on my drawings, okay. So this one is bus, and bus speed is velocity of bus, this one is 10 meter per second, and this one is 1 kilometer away from this, and scooter wishes to overtake this bus in 100 seconds. So now we have to find out the velocity of scooter is what, so that he can easily overtake the bus, okay. Now the relative velocity of bus, relative scooter is with respect to bus is BSB equal to distance by time. Distance is 1000, time is 100, so 10 meter per second. Now we know that BSB equal to BS minus BB, so this one is 10, we have to find out this one, and this one is also 10, so 10 plus 10 equal to BS. So velocity of scooter will be 20 meter per second. If the speed of the scooter is 20 meter per second, then he can able to overtake the bus in 100 seconds, and the bus is 1 kilometer away, if the bus is 1 kilometer away, okay. So which option is correct here, sir? Option B is the correct answer. So option B is the correct answer. So what we learned today, we learn what is relative velocity and the 3 different cases of relative velocity, okay. And we do some previous year questions. This question is came in service NEET. This question is came NEET 2009. There is CBSE PMT. This question is came CBSE PMT. There is PMT 2009. Okay. And first we learn what is relative velocity and the different cases of relative velocity. After that we do 3 different numericals which is came from the topic in previous year questions, that means NEET and JEE. Okay. So I hope this lecture is helpful for you to understand the relative velocity and the numericals of relative velocity, how they came actually, okay, how to solve this one. So have a nice day, take care.